Welcome back, students. This is section 9.4. I was going to do a few problems for you today. Probably number 2, 3, 4, 7, and 10. I had those requested, so let's go ahead and jump right in. Alright, so number 2. First, try to solve the equation by factoring. If you're unable to solve it by factoring, solve the equation by using the quadratic formula. For equations with solutions that are irrational numbers, give the exact solutions and approximate solutions to the nearest thousandths. So irrational means that it is not like it's not a whole number, it's not a countable number, it's not a fraction in the normal sense like 1/4. So 1/4 is actually a rational number. 1/3 is a repeating decimal. So the square root of numbers like the square root of 5 is irrational because it doesn't have a repeating decimal. So let's just confirm that. So if you take the square root of 5, let's clear that. Let's take the square root of 5. You'll notice that there's no order to the square root of 5. So that would be considered irrational. In that case, give an exact solution, meaning the square root of 5 needs to be in your answer. Okay, so we have this equation. 4t squared equals t plus 4. So let's rearrange this equation and solve for the variable t. To do that, we need to move everything over to the left side and get 0 by itself. Okay? So subtract t and subtract 4 from both sides. So we're going to get 4 t squared minus t minus 4 equals 0. Okay? So just subtracting t and subtracting 4 from both sides allows you to cancel the t and allows you to cancel the 4. Left with 0 on the right. Now it asks us to factor this, so let's see if we could factor this. So some possible factors might be 4t. We need to get a 4 on the beginning and we need to get a 4 on the end. I don't think that this is going to be factorable, so but we could try. We could still try. So if we put 4t at the beginning, we have to put a t here because 4t times t is 4t squared. Now in trying to figure out what goes next, in these spaces here, we can either put a 4 or a 4 and a 1 because 4 times 1 equals 4. Or we could put a 2 and a 2 because 2 times 2 is 4. One of these has to be negative. Now, let's see. This is not going to work out. If I put a negative 2 here and a positive 1 here, when I FOIL this, and positive 2 here and a negative 2 here. So when I FOIL this, I get 4t squared plus 8t minus 2t minus 4. And that gives me a middle term of 6. So that doesn't work. Let's try 4 and 1. So if we go 4t, let's go plus 1, and t minus 4. FOIL this, we get 4t squared. 4t squared, the first two terms, and then minus 16t, this definitely isn't going to work, plus 1t minus 4. So that gives us a minus 15 in the middle. That doesn't work. So it looks to me like this is not factorable. Okay, so let's start over and use the quadratic equation. Okay. So rearranging the equation, again, 4t squared minus t minus 4 equals 0. So a is equal to 4. b is equal to negative 1 and c is equal to negative 4. The coefficients in front of each one of these is 4, negative 1, and negative 4. C is negative 4. Okay, so quadratic equation says negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. Alright, plugging in the numbers, the negative of a negative 1 is positive 1, plus or minus b squared, negative 1 squared is 1, minus 4 times 4 times c, which is negative 4. Okay, so sorry I run out of room, but it looks like I have 3 4's multiplied and there's 2 negatives. So this is going to be 1 plus 64. Okay, so that's the square root of 1 plus 64. So the square root is 65, and this is all over 2 times 4, and 2 times 4 is 8. So here is this. So let us write it as 1 plus the square root of 65 over 8, and then, or 1 minus the square root of 65 over 8. These are our two solutions, and these would be the exact solutions. Okay. Now, the way that they've written it here is a little different than the way that they have it written in the book, or as the answers imply here. And they separate answers by a comma. So apparently this right here is supposed to be a comma. It's kind of hard to see, but it looks like a comma. So I'm gonna try to remember these two answers, and I'm gonna see if it'll let me plug in these two answers here. So 1 plus square root of 65 over 8, and 1 minus square root of 65 over 8. And let's see if it'll take it. So 1, let's do the fraction, I guess, first. 1 plus the square root of 65 over 8. Press to the right, go arrow right, comma, and then do the same thing but with the minus sign between the 1 and the radical 65. I just want to see if it will accept this as an answer as well. Alright, I'm going to press enter. I guess it won't allow me to check it, but it should accept that as a valid answer. Okay, and then you can take the square root of 65 and get a number, and you can approximate the answer. And these the two answers, approximate answers, are over here on the right side. Okay, so that one took quite some time. That was number 2. Let's see if number 3 is any easier. So again, kind of the same thing. Ask to factor if possible first. If not, use the quadratic equation. So bringing everything to the left side, we got 2s squared minus 4s. Minus 4 equals 0. Okay, so hopefully you understand I'm just moving things over by subtracting both of these from both sides. Alright, now we can factor out a 2, and that might help us. Okay, let's try to see if we can't factor this. S squared minus 2s minus 2. So the lead term here is s squared, so it's going to be s and s. The last term is negative 2. There's only 2 factors to give you negative 2. That's a negative 2 times 1 and positive 2 times negative 1. So we can put a negative 2 in here and a positive 1. Or we can put a positive 2 and a negative 1. Neither one of these appears to give me the same equation as I have up here. Because when I FOIL these, this top one here gives me s squared plus 1s minus 2s minus 2. Okay, so we can subtract 2s from s. That gives us a negative s. We needed a negative 2s in the middle. Okay, if you FOIL the bottom one, you're going to get s squared. You're going to get s squared minus s plus 2s minus 2. So we adding those middle terms, we get a positive 1s. That's not what we want, so we can't factor this. So we're going to have to use quadratic. Alright, so we tried. So let's start over, this time using quadratic. Identifying your a, b's, and c's. Okay, so it's going to be 2s squared minus 4s minus 4 equals 0. So your a is equal to 2, your b is equal to negative 4, and your c is equal to negative 4. So the equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. So plugging in our numbers for their letters, we get a negative 4, so that becomes 4, plus or minus the square root of b squared. Negative 4 times negative 4 is positive 16, minus 4 times 2 times negative 4. Okay, so we have a negative here, and we have a negative here, so those are going to cancel. 8 times 4 is 32, so we're going to have 16 plus 32 under the radical. Okay, and 16 plus 32 is 48. And on the bottom we're going to have 2 times 2, which is 4. So rewriting this, we get 4 plus or minus the square root of 48 over 4. Now let's deal with this square root of 48. This is really not taught explicitly, so they just kind of assume you know how to transform this radical into its reduced form. What we're looking for is factors of 48 that have a square root. So for instance, if I wrote this as 4 times 12, then I could take the square root of 4 and pull a 2 on the outside. And that brings it to 2 rad 12. Okay, so this now comes on the outside. Now 12 can be written as 4 times 3. So we have 2 rad 4 times 3. Again, we can take the square root of 4 and pull another 2 out. So we got 2 times 2 on the outside, rad 3. So this actually becomes 4 rad 3. Okay, so we started off with 48 and we end up with 4 rad 3. That's the same, it's the same answer, but just a different version of the same answer. So rewriting it, we got 4 plus or minus 4 rad 3, and all of these are over 4. Now, so long as the lead coefficients in all of these have a common factor, then you can divide by a common factor. So we can divide everything by 4, and we can reduce the top and the bottom. Again, this only works when everything has a 4 or a 2 or some factor that's common between all three of them. So we're dividing everything by 2 or by 4, we get 1 plus or minus 1 rad 3, which is just rad 3 over 1. Okay? So now we got C. Why are we getting a different answer here? making sure that I did this right. Oh shoot. Oh yeah, I'm sorry. I'm looking at the wrong place. So I was looking for number 4. So if you take this answer and you go up here, it is 1 minus the square root of 3 and 1 plus the square root of 3. That's the exact answer. And then if you take the square root of 3, you can get a number. So let's just do that now. 1 plus the square root of 3 is going to be 2.732. So 1 plus the square root of 3 should be equal to 2.732. Let's do a calculator check. So take the square root of 3 and then add 1 to it, and you get 2.732, which is exactly what they got here. Okay, so we're in this about 16 minutes. I think I'm going to go ahead and stop for now and call that good for number 2 and number 3. I think I'm not going to do number 4 because it's much the same as number 3, 2 and 3. I think perhaps I can do number 7 and 10 real quick, so let's go ahead and do number 7. The area A in square meters of a rectangle with a perimeter of 60 meters is given by the equation 30w minus w squared, where w is the width of the rectangle in meters. What is the width of a rectangle if its area is 200 square meters? Okay, so let me just go back over this. So we're given a perimeter of 60. And the perimeter, the area, okay, so there's two things. There's an area formula, and then the perimeter is 60. We're asked to find the width of a rectangle, okay, with the area of 200 square meters. Okay, so the perimeter really doesn't matter. It's kind of inconsequential to this problem because we do not know what the length of the rectangle is. But we do know what the area is. The area is 200. So if we plug in 200 for the area, we get 200 equals 30w minus w squared. Okay, so let's solve this equation for w by bringing over everything to the left side. So we're going to subtract 30w and add w squared. So we're going to get w squared minus 30w plus 200, and these all cancel. So this equals 0. Now let's go ahead and try to factor this if we can. This might be factorable. So if we look to 200, if we think about 200 can be written as 220 times 10. Okay. Now there's other ways to write this. For instance, you can multiply 40 times 5. And the reason I chose to do 20 and 10, I believe that this is actually correct. Go ahead and place your w in here as well. If I put a minus 20 and a minus 10, if you FOIL this, you're going to get w squared, w times w. W times minus 10 is negative 10w. And then the inside terms is negative 20w. Negative 20 times negative 10 is positive 200. And that's what we want. So let's add these two middle terms. It works out. We get a negative 30w in the middle, which is what we had to begin with. And everything else looks good. We got a positive 200 on the end and a w squared. So we found out our two factors. Alright, so let's remember that. W minus 20 times w minus 10. And we're going to solve for w. Alright, so let's rewrite this. So w minus 20 and w minus 10. W minus 20 times W minus 10. So there's two solutions, two things that will make this equal to 0. So if this is 0 or this is 0, then the product is going to be 0. So let's set W minus 20 equal to 0. Solve for W. Add 20 to both sides. So W equals 20. That's one solution. The other one is adding 10 to both sides. We get W equals 10. So we get two solutions. Now, one of these two, I guess, is going to be the correct one. The area of a rectangle with a perimeter of 60 is given by this equation, where W is the width of the rectangle in meter. What is the width of the rectangle if its area is 200 square meters? So let's check to see why they exclude 20 as an answer. Now if we might have to use the 60 after all. So the perimeter, if this were W, then this would be W. If this were L, then this would be L. So the perimeter equation is 2L plus 2W. Okay. Sorry, let me see. So the perimeter was 60. We don't know what L is, but we know that W could be either 10 or 20. So we plug in 10, we get 20 here. If we subtract 20 from both sides, we get 60 minus 20. Oh, 60 minus 20 is 40. Let me bring that, I wish I could bring that back up. I didn't mean to close that. I believe we had something like this. 60 equals 2L minus 2 times W, where we're going to try 10 in for W, and then we're going to try 20 in for W. So this was minus 20. So adding, sorry, plus 20. So let's subtract 20 from both sides. So in this case, if we divide it by 2, we get L equals 20. Okay, and if we plug 20 in here, that would give us 40. And if I subtract 40 from both sides, I get 60 minus 40 is 20 equals 2L. Dividing both sides by 2, I get L equals 10. Alright, so what I think what's going on here, I'm still not sure why they only included one answer, but we have a rectangle that measures 10 by 20. Okay, if we wanted to, we could rotate that rectangle, and it could be 10 by 20. In both cases, it's a 10 by 20 rectangle. I don't know why they've chosen to say that the smaller side is the width. To me, it's debatable which one's the width and which one's the length, but they've chosen to only include one answer here, and that's the smaller one. So they say the answer is 10. So again, I think both of them shows if you added up the perimeter, if you add all these numbers together, you are going to get 60. Okay, so 20 plus 20 is 40, 50, 60. Same is true for this rectangle here. 40 plus 10 plus another 10 is 60. And if you multiply 20 times 10, you get 200, and that's the area, 200 square meters. Okay, again, not quite sure why they only included one of those two answers, but it should be 10 or 20. And then the last one was number 10 here. So we're given this equation for the height of a model rocket. It's launched at an initial velocity of 200 feet per second. The height is measured in feet. H represents the height, and T represents the time in seconds after the launch. It's given by this equation. We're asked to find out how many seconds after launch will the rocket be 600 feet above the ground. So let's go ahead and plug H equals 600 because the height is 600 feet. So plugging in 600 for h. We get 600 minus 16t squared plus 250t. So this is a physics equation, an object in free fall. Let's rearrange the equation by adding 16t squared to both sides and subtracting 250t. So this comes to the other side, to the left side, as 16t squared minus 250t plus 600 equals to 0. We're able to cancel these terms on the right. Now, I would like to try to reduce this if possible. If you can try to take and divide by 4, is 250 divisible by 4 without getting a decimal? So 250 does not appear to be divisible by 4 evenly, so we're kind of stuck with this. So we're going to probably be best to use the quadratic equation, because this is not going to be easy to factor. Yeah, I think that's our best bet. So let's set a equal to 16, b is equal to negative 250, and c is 600. So b squared negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in a, b, and c, so we get negative of a negative 250 is 250 plus or minus the square root of 250 squared. Negative 250 squared is, this is going to be a tricky one to do without a calculator, but let's see. It is going to be I believe that is the correct answer. I am looking for a calculator now. Let's see, 200 times 200 would be 40,000. So 250 times 250 would be 62,500. That seems to be good. Minus 4 times a, which is 16, times c, which is 600. Okay, so for some reason I've decided to do this problem without a calculator. And unfortunately, pulling the calculator up now is, I think I'm going to lose the work. And this is all going to be divided by 2 times 16, which is 32. Alright, so let me see if I might be able to do this in my head here or on paper. So let's take 4 times 16, or 4 times 16 times 600. So 4 times 600 is 2400, and 2400 times 16 is, sorry for this manual calculation here, but I just happen to not have a calculator with me. Boy, I'm just doing this all wrong. Let's try this again. 2400 times 16. So we got 14,400 plus the part of the challenge here is too, my numbers are, this pen here I'm using is not allowing me to line up these numbers, so let's see, these are lined up here. That's 0, that's 4, that's 8. Alright, hopefully we got this. 38,400, so that's going to be 62,500 minus 38,400, and that's going to be the square root of that. All over 32. Okay, so again we're doing manual calculations here. 62,500 minus 38,400, and we are going to get 24,100. We need to take the square root of 24,100, and I am going to write this problem down and grab my calculator. So we got 250 plus or minus the square root of 24,100 all over 32. Okay, so when I pause this and come back, I'll have a solution for you. I trust you can do the calculations on your calculator just as good as I can. Actually much better, because I should have had my calculator in hand before I started this problem. But I'll see you back in just a second. Okay, so I did get the correct answers. We were on the right track. The answers are matching up. It's 2.96 and 12.66. And the square root of the number we were looking for, which was the square root of 24,100, was 155.24. So we had 250 plus or minus 155.24, and that answer divided by 32. And that gives you those two solutions. Okay, so thanks for watching. And it's been a long video, but this was a challenging lesson, wasn't it?